Welcome back to a new video. In this video, we're going over Carnage. Carnage is a new ROM released by TryHackMe. The ROM is about investigating a PCAP file captured from an infected machine. So basically, in this ROM, you will apply your analytical skills to analyze the malicious network traffic using Wireshark. So this is a blue team ROM to get yourself familiar with investigating PCAP file using Wireshark. Now the scenario is like that. This guy has opened a Word document. The Word document actually contained some sort of macro routine. The macro routine has downloaded further malicious files to the victim machine where they infected the machine and then started to exfiltrate data. That's what happened. Now, from the description here is saying the SOC department immediately received an alert from the endpoint agent. The endpoint agent is a piece of software you install on the machine you want to track. The endpoint agent actually gathers all of the important events, incidents happened on the machine and sends it to a central log aggregator like Splunk, for example. So received an alert from the endpoint agent that Eric's workstation was making suspicious connections outbound. The PCAP was retrieved from the network sensor and handed to you for analysis. The network sensor is any kind of software or program you installed on a central device to gather all of the important traffic and incidents. An example of network sensor is Snort. So now you are the instant responder. You are analyzing the PCAP file that was retrieved at the time the incident happened. So what we're gonna do now, you're gonna split the view here and open the browser, open the Wireshark file, and we start answering the questions. The first one: what was the date and time for the first HTTP connection to the malicious IP? So here we look for filtering HTTP traffic. So we go back here and we type hey HTTP. So looking at the first traffic, we right click, follow TCP stream, and we find out the exact date and time of this traffic. No, I'm sorry. It's going to go back to HTTP. And we look at something called arrival time. So taking a look here, time is September 24, 2021. And this is the exact hour, minute, and second. So here the answer is this one. Make sure you format the answer according to the format requested by the question. So that was the date and time where the first malicious request was made from the victim machine referenced by this source IP to the destination IP here, which is malicious. Next one: what is the name of the zip file that was downloaded? Now we'll take a look again at the same packet. We right click and follow the TCP stream to get everything more clear. So we see here the request path, and we take a note of the file, documents.zip. That's the name of the zip file that was retrieved. So apparently, guys, the request was made to this URL to retrieve a zip file. Now the next question is, what was the domain name hosting the malicious zip file? Taking a look again at the same packet, but here we take a look at the response section, the server response. Looking at the server response, we see here information about the domain. Hopefully, let's see here. Nope. What was the domain hosting the zip file? I think we need to take a look at another packet. No, here it is. So this is the host or the domain name. Actually, you need to take a look at the HTTP request. It contains the host name. So without downloading the file, what is the name of the file in the zip file? So this is a zip file. Upon extraction, there were several files extracted, or one file extracted. We need to find out what was that file. Again, at the same packet, guys, take a look here. .chart-15, we have several numbers, and take a look at the extension .xls. So this is an Excel file. Now this is the file that was extracted after downloading or after extracting the documents.zip file. not zip. So this is the answer. What's the name of the web server of the malicious IP from which the zip file was downloaded? Now again, the name of the web server is clear in the HTTP response. So there's a field called server and the value is light speed. So this is the server name. And again, the server version is referenced by this field, x powered by, and the version is PHP 7.2.34. This is for both these two questions. Now, next one is a bit not tough, but requires a bit of skills in the using Wireshark filters. So malicious files were downloaded to the victim host from multiple domains. What were the 3 domains involved with this activity? So now, if you make a review of what happened, so the victim downloaded a zip file, right? The zip file, upon extraction, yielded an Excel file. Upon opening the Excel file, it seemed that several connections were made to these domain names. So the Excel file here also could contain macro routine to make connections to 3 domain names, malicious domain names, to retrieve further malicious files to infect the machine. So this is kind of drive-by download Trojans. So now we need to take a look at these domain names from which the malicious files were retrieved. So we go back, but if you check the hint here, look, check HTTPS traffic, narrow down the time frame between 1645.11 and 1645.30. So here we have to use some sort of time filters so that the time filter or time frame is greater or equal than this, all right, or lesser or equal than this. Let's construct the filter now. So first, TCP dot port equal 443, and we use and as a conditional statement, frame dot time. So here we define the time greater than or equal to, open the double quotes, and inside the double quotes we type in the time. So September 24, 2021. We follow the exact same formula used in the packets. As you can see, the month, the year, and the time. That's why I'm using this formula. So 16:45:11 greater than or equal to this time. Don't forget the parentheses. Yeah, so we have 2 parentheses here, and now use ampersand to indicate the next frame time, frame dot time lesser than or equal to. So we're gonna copy that and only modify on the machine is slow, I know that. Okay, copy using the Control C, and here let's check out, it's 30. All right, so also we have the double quotes. Don't forget the double quotes. Here's the first one, and here is the last one. So, but still we have something wrong here. That's why the filter is not working. It doesn't show any green sign. So here we have also double quotes. TCP port equal 443, and let's cancel the spaces here. So 2 parentheses here and 2 parentheses there. Frame time, frame dot time. TCP port equal 443. Honestly, I don't know what's wrong with that. Frame dot time and frame dot time lesser than or equal to this date. So this query seems to be wrong, but we're gonna need to find out why. is it the double quotes? Okay, let's make some space here and one here. I don't think it's a spacing, but I'm just trying out different ideas. So maybe we need to put spacing here as well between the day and the month. Ah, now it's working. So now we are in front of HTTPS traffic. To find out the domain names, we need to take a look at the packets where there is client hello from the source, which is the victim machine, to the destination, whichever it is. The first client hello packet is labeled here. You can right click on that, follow TCP stream, and this marks the first domain name. Also take a look at, or take a note of the certificate provider we're going to need it for the next question. This is the SSL certificate provider, godaddy.com, judging by the URL here, http search godaddy.com. Close. That's the first domain name, guys. Now we go back to the query, and again we look for the next client hello packets. Since, as you know, HTTPS traffic is encrypted and we can't just see everything clearly, the only way to extract a domain name is to look at the client hello packet, which marks the first connection attempt from the victim to the destination here. So we don't care about these. Let's scroll down, find another client hello packet here. Scrolling down, scrolling down, scrolling down. Server hello. I think since we have server hello here, I think we have another client hello one. So client hello here. Now let's take a look here. Transport layer security, client hello. Okay, we're gonna need to follow that stream, follow TCP stream, and this one is making requests to Microsoft. So this is not the one we want. Folder back. All right, scroll back down to find another client hello. So here's one. This one is making requests to Windows. Also, we don't want this. These are definitely not malicious domain names. Scroll back down. So this is also a client hello here. Let's take a look at this one. Hopefully this is the second malicious one. Yeah, this is also another malicious domain name. So that's the next one. And the last one, there is one last left. Let's take a look at that. Client hello here, finished with that one. Looking at the last client hello packet here. Hopefully we're gonna find that quick because the stream is too big. So client hello, follow TCP stream. Yeah, that is the last one. So right now you have found the 3 malicious domain names, right, to which or from which the malicious files were downloaded. Now, which certificate authority issued the SSL certificate to the first domain from the previous question? We already answered that. Now, next one. What is the host? What are the 2 IP addresses of the Cobalt Strike servers? Read that again. What are the 2 IP addresses of the Cobalt Strike servers? Use VirusTotal to confirm if IPs are identified as Cobalt Strike C2 servers. So now, after we understood how the infection happened and what was the first attack vector, how the malicious files were retrieved and from which domains were retrieved, we are now taking a look at the command and control servers from which all of the commands, all of the files, all of the infection happened. So the command and control server represents servers controlled by the attackers to send commands to your computer or control it, let me say. So now we're chasing the attackers. So to find these IP addresses, you're gonna go back and so let's do that again. 2 IP addresses, right? So now we're gonna go back to the old filter here, right? And we need to examine the destination IP addresses, all of them. So at the first glance, it seems kinda boring, right? But I'm gonna guide you through a way to find or extract all of the malicious IP addresses, specifically, actually only this destination IP addresses from Wireshark. Now, unfortunately, the machine doesn't have T-Shark, so I'm gonna, guys, show you the command that you might use in the future to just extract any field from Wireshark instead of just going one by one. So we're gonna use something called T-Shark, and we're gonna here type the formula JSON, or the type, it is JSON -e. Here we define the field that you would like to extract. Now, since we are interested in extracting destination IP addresses, we're gonna type here IP.destination. Then we're gonna type the input file name. The file name is called Carnage.pcap, and then we're gonna use pipe that to grep, and use a regular expression. The regular expression will filter for numbers. So we're going to type number from 0 to 9, because IP addresses are numbers at the end. And at the end, we're going to sort that, or pipe that to sort the results. That's the command you need, right? But T-Shark is not uninstalled on the machine, so it's not going to work. Instead, or alternatively, we're going to go back to the stream here, go to stats, and then we check out conversations, go to IPv4, and you can also select copy as CSV. But the way I did that, I went through all of the IPs here, destination IP, and examined them not one by one, judging by the look of the IP. And what I found that these 2 IP addresses belong to Cobalt Strike. Let's take the first one. The first one, as you can see, exists in the list here. If I scroll down, this is the one, 185, 106, 96, 158. So you go to Wireshark, virus total, enter the IP, community tab, and you check here the comment saying Cobalt Strike server found. The same for this IP address. That's how you find the IP addresses. Next one, what is the host header for the first Cobalt Strike IP address from the previous question? The first one is this one, not this one. I made a mistake actually. It should be in the opposite order, or the reverse order. This is the first IP. How to find out the host header? Since we're asking about the host header, we need to examine the HTTP traffic. So we X on that, and we type in a filter to filter all the traffic for this IP address. Okay, now here we see we have HTTP traffic. Let's take a look at the first one. Any packet would work. Any packet contains GET or POST request would give you the host header. So examine TCP stream, and we see here the host header is ocsbverisign.com. What is the domain name for the first IP address of the Cobalt Strike server? So the domain name that corresponds to the IP address. So now we go to relations, we scroll down to something called historical SSL certificates, and we find the first domain. Likewise, we find the next one. What is the domain name of the post-infection traffic? Okay, so here we have another milestone in the analysis. And the first milestone is we understand how the infection happened. A zip file was downloaded. Upon extraction of the zip file, there was an Excel file. The Excel file, upon opening, it spawned a macro routine. A macro routine retrieved or downloaded or contained, let me say, contained commands to retrieve files from these domain names. So the files were downloaded from the domain names and opened and infected the machine. Now, Also, we checked and we found the command and control servers used to send back and forth the commands to the infected machine. After we found the command and control servers, we want to now find what happened. So regularly when you infect a machine, what happened after the infection is data exfiltration. Data exfiltration happens through several methods. One of them is DNS exfiltration, but here we're looking at post-infection traffic. So here we're looking at post requests. So we go back and we use a filter to filter for hey HTTP request method equal open double quotes post. Alright, so these are the post requests sent from the victim machine to the command and control servers. Now, not necessarily the command and control servers. Attackers are smarter than that. They would use separate servers for data exfiltration. Now, as you can see here, the post requests are not looking good. We see encoded characters and regular, healthy, natural requests don't look like that. So we're gonna investigate the first one, full TCP stream, and see the question again. What is the domain name of the post-infection traffic? This is a domain name. That's the domain to which the data were exfiltrated. What are the first 11 characters that the victim host sends out to the malicious domain involved in the post-infection traffic? The first 11 characters are started, or you can start counting from Z until you count 11 characters, you reach 9. What was the length for the first packet sent out to the server? You can find the packet length by closing this and taking a note of, let's go back to the filter and taking a note of the first packet here. The length is 281. What was the server header for the malicious domain from the previous question? So the server header, we can go back to the packet and we check out the server header here. This is the header of the server. Again, the malware. Now the next one is kind of tough. Let's take a look. The malware used an API to check for the IP address of the victim's machine. What was the date and time when the DNS query for the IP check domain occurred? So what was happening here? The malware, right? The malware that was retrieved from the command and control server made a DNS request. The DNS request was made to an API that checks on the IP address of the machine. We need to find out what was the exact date or what was the first occurrence of this DNS request. So the first thing is filtering for DNS request. DNS, and make sure you filter in ascending order, oldest to newest. And then we take a look at DNS queries. These are DNS responses, so we exclude them from the analysis. We scroll down all the way down. That's how we narrow down the search. And now we take a look at DNS queries. We need to find out a domain name that contains the word IP or API, which marks a DNS request to check on the domain name, the IP address. Let's see here. So upon inspecting on the domain names here, we see, let's see here, scroll down, way down, way down. Okay, so we have one. Where was this? So this one is a request or DNS request to API ipfi.org. Check out the time. But this is not the first one because the answer here is different. I'm gonna check. I think we skipped the first one. Let's look more closely on that. Yeah, this is the first one. This is the first occurrence or the first DNS query made to the API. And you take a look at the date and time, September 24, 2021, 17:00:04. That is your answer. What was the domain name in the DNS query from the previous question? Again, it's clear, API ipfi.org. Looks like there was. Now here we have also another milestone in the challenge. looks like there was some malicious spam activity going on. What was the first mail from address observed in the traffic? So we were looking for finding about email messages sent to the infected host and marked as a spam. We need to extract the mail from or the sender. So here we look for inspecting SMTP traffic, SMTP packets. All right, what we're looking for here, we're looking for the sender. The sender needs to be, or the victim address here, which is this one, needs to be in the destination field because it is the one receiving the message, right? So these are not our packets. We scroll down and we try to find out. Yeah, so here we have the victim IP address under the destination field, which means that they are on the receiving end of the email message. So now to find out about the spam messages, we take a look at the info. The info gives you some clues about what the message is about. The first one saying your SMTP service is disabled. Please check by your mail server provider. Next one is the same. Here we have some encoded strings. If you scroll down, we see here regular messages coming from servers. Here we have a message saying pleased to meet you. And also if you scroll down, we see regular messages coming from Office 365. Requested mail action, okay, completed. Seems like regular conversations, right? But if you take a look at the first one we saw, or we witnessed this one, your SMTP service is disabled. So why would you receive a message from weird address, right, saying your SMTP service is disabled, right? Now let's check. Actually, the answer is in the next one. So that's why I'm checking directly the next one. So follow TCP stream. Now we see here the mail from is Farshin at mailfa.com. So to find out if actually, or if the actual mail provider has sent a message saying that you have a problem in your email, so to distinguish and to find out if this message has been actually sent from the mail provider, because sometimes when you send a message to someone, if you made a typo in the address of the receiver, you would get a message back from the provider, say Microsoft Gmail, saying that your message has typos or it could be delivered. So such errors could happen from time to time, but we need to find out if that actual error has been received from the real provider. So to know that, we have to find out what is the email address of the victim machine or the owner of the victim machine. If the email address happens to be or corresponds or maps to this domain name, then we're gonna skip that and we check mark on that it is green. So we close that SMTP. And let's take a look at one of the messages sent by the owner of the victim machine. Scroll down, scroll up. This one is okay. Right click, follow. Now, check out the from. From is Ravi at sreratana.com. To this one. Check out the domain name. Domain name is actually very different from the one we saw earlier, which means that the one who sent out this message is actually a spammer. Not this message actually, the last one, that message. So that's how you find out the answer. How many packets were observed for the SMTP traffic? That's easy. We're gonna go back to SMTP and go to statistics, go to protocol hierarchy. This displays breakdown of all the protocols captured in the file with the corresponding number of packets. We highlight simple mail transfer protocol and we note down the number. And this is your answer. So that was today's video. I hope you enjoyed the video and hope you found it enjoyable, informative as well. See you in the next video.